Okay, so, ooh, I guess I don't want to do that. Okay, so this is just a little script. I guess it's more. I lied a little bit. It's like okay, it's 160 lines, but so this is a script which it really kind of starts here. Actually, this is loading in a previous version that is saved from this, so I don't have to go through all the data sets again. But this is basically going through and it's going to do a model data comparison on this big ocean model hindcast. So this is the location. This URL here is the access to the model output itself. So I go into the model output. I open it up with this NC toolbox, and I open this NC object, and then from that I can get the time and the latitude and longitude. So from that, from the latitude and longitude, I look at the extents of that, and I'm going to look for a variable. I'm going to look for variables that have eastward seawater velocity, because I want to compare currents between the model and the data. So I don't want to find data sets that don't have current in them. So then I build up this query structure here. So here's a bounding box, and here's the start end point that I'm going to go to. I'm going to hit this OpenDAP search service, and this is the service that has harvested the metadata from all these different observations from the fisheries, from Woods Hole Oceanographic, from USGS, these different thread servers. It's actually already gone and done. Every hour it goes out and pulls metadata from there. So I build up this thing called Q, and then I do open search on the structure, and it brings me back these links. And then I find the OpenDAP links in there. So then I start plowing through. Actually, now here's a little bit of like special sauce where I'm actually throwing out some stuff that I didn't like. So it wasn't quite completely automated. Well, this is like stuff that you don't like to show. But But basically, oh, and then I had to sort the links, and so that they're in ascending order, so that I can easily add more stuff on the end, because there's no guarantee that the links are going to come back in any particular order. So then I start just plowing through here. Basically, I'm going to do a base map here, but so I plow through these things. This is the way I'd normally do it, one to the end of this thing. And so I go through and I find the ones that have the standard names, and this is kind of cool. Actually, I use NC units to convert anything I find to meters per second, no matter what it is. Whether it's millimeters per second, or whatever, this NC units thing will actually convert units. So a little bit further down, so I'm pulling the latitude and longitude and the water depth. Here I'm finding the index of the model that's closest to the observational data, just with a real simple, give it the vector, all the positions in the model, and then the one position of the observation. This is in a loop, of course, and then here I'm actually doing the interpolation. I'm pulling the 3 surrounding nodes, and then I'm gonna do basically. Oh. And here's more tricky stuff to actually, if I'm within a certain, so I'm going to pull in depth. I'm going to pull the closest level in the model that's to this particular depth in the ocean. But if it's too close to the bottom, I'm actually not going to use the depth of the model. I'm going to use the depth of the model instead of the depth of the data, because the depth in the model might not be the same as in the real world. And it's more important to be 5 meters off the bottom in the real world or the model than to be at the right space in the real world, which may be below where the model was actually even representing. So anyway, so then I go down, we pull the data, and then I start doing this analysis. I make the vectors complex. So actually this thing only basically interpolates everything onto the same time base. Okay, so when I end up with this, I have the latitudes and longitudes and depths, but then I have these structures that contain the observations and the model, and then I save it. Okay, so this is really the workhorse routine that's created these identical time series of model and data. And so from there on, I save this, and then the next little script that I run actually processes this. So that's convenient, because that's the end of this. So in the next step, I'll show you the next parts.